Hi, Calc students. First of all, I hope you are surviving this distance learning okay at a minimum, that you are all staying safe and healthy. And I really hope that I get to see all of you again in the classroom because that is my favorite way to learn. Even though, to be perfectly honest, I really don't see that happening at this point in time, unfortunately. So hang in there, let me know what you need, and take care of yourselves. All right, this last unit before we prepare for the AP exam is differential equations. And we've seen these before, so it's a bit of review and a bit of extension from what we've already seen. So hopefully this unit won't be too bad to learn distantly. Starting off, we are taking a look at slope fields again. So we have seen these, we have sketched graphs on slope fields. Now we are going to identify which slope field goes with which differential equation, which is just another fancy way of saying derivative. And we are also going to learn how to create our own slope field. So as a reminder, you all know this, the derivative is the slope of the tangent line. So when you're looking at a slope field, it's just using the derivative to plot what the slope of the function would be at all of those different points. As a reminder, when we integrate, we get that plus c, that constant of integration, because that function could be shifted up or down, giving us a different solution. So that's why these slope fields kind of look like they fail the vertical line test, and it's just because there's so many different options for that original function. All right, so starting off, we've got 4 slope fields and 4 derivatives, or 4 differential equations. So what I noticed with that first one, we've got sine of x. Now I know that the sine function is a wave. So I'm looking at these 4 slope fields, and the only one that is a wave, like the sine function, is c. Now I could also take some points and sub them in and find the slope at those points to make sure they match. But in this case, to save time, we are going to use our knowledge and just say that number 7 matches with letter C. Because the other ones will actually take a little bit more thought process, even though they look a little bit more basic, but it's hard to match those because they are so similar. So I'm actually going to start with number 10 because I think it's easier of the 3. And what that says is that the derivative matches the x value at that point. So our y value has nothing to do with it. And when we look at those 3 graphs, there's only one of them where every x value has the same slope. So I want you to take a second to look at those 3 that are left and see if you can figure out which one matches with number 10. The slope is the x value. And I hope you came up with B. So let's go over why B is the correct answer for this slope field. Again, each slope should be equal to the x value. So if you look along the y-axis, the x value is 0. All of those slopes are plotted as a horizontal line, which means they have a slope of 0. And then moving to the right, we have slopes of 1. And then the slopes get a little bit steeper. So it looks like a slope of 2, and then 3 and 4, and so on. And going off to the left, we get slopes of -1. It's kind of that mirror image, -2, -3, and so on. So along each vertical line, which if you remember, when you graph an equation in the form of x equals, it's a vertical line. So that's why all of those slopes line up vertically. Probably the next easiest one to look at is number 9 because it just involves the y value. So now we've got this narrowed down to A and D, and take a second to see if you can figure out which slope field matches with 2 minus the y value. And hopefully you came up with A for a very similar reason that number 10 was B. If you look, each horizontal line has the same slope. So at 2, when y is 2, 2 minus 2 is 0. So we have all of those little horizontal lines which represent a slope of 0. And then as we go up from there, 2 minus 3 is -1. So we've got this row of -1 slopes and then a row of -2 slopes. And going down from there, 2 minus 1 gives us a slope of +1. 2 minus 0 is a slope of 2, and so on. which leaves D as number 8. So this is our x minus y slope field. So for example, at all of these points where x equals y, we get a horizontal slope or a slope of 0. So at 1, 1, 1 minus 1 is 0. At 2, 2, 2 minus 2 is 0, and so on. And then you can just pick other random points and take the x-coordinate minus the y-coordinate to get the slope at those points. So you kind of see along these diagonal lines where they have the same slope. It's kind of that x equals y type slope field. In this last example, we will be creating our own slope field. This is time consuming, so what I'm going to do is generate a few points for you, and then I'm just going to tell you what I got for the other points. So what we're going to do is take these points and sub them into the differential equation that we were given. So x divided by y. Filling in this table, negative 2 divided by 2 is negative 1. So at the point negative 2, 2 on the graph, we will sketch a little line that has a slope of negative 1. So think about drawing like a perfectly diagonal line that would aim right towards the origin. Those lines would have a slope of 1. Negative 2 divided by 1 is negative 2. So at the point negative 2, 1, we would create a slope of negative 2. It would be a little bit steeper than the slope of negative 1. Negative 2 divided by 0 is undefined. Vertical lines have an undefined slope. So at the point negative 2 to 0, we would create a vertical line. Now to extend that, everywhere that y is 0, we would have an undefined slope. So all along this x-axis, I'm just going to go ahead and sketch those little vertical lines for our undefined slope. Negative 2 divided by negative 1 gives us a slope of 2. So at the point negative 2, negative 1, we're going to plot a slope of positive 2. So I'm going to try and mirror that slope of negative 2 as best I can, but in the positive direction. Negative 2 divided by negative 2 gives us a slope of 1. So we go to the point negative 2, and again, try and get that perfectly kind of diagonal line, but this time with a positive slope. Now moving to the negative 1 column, negative 1 divided by 2 gives us a slope of negative 1/2. So going to negative 1, 2, and this line will be shallower than that slope of 1, but still falling. So you're just sketching these slopes to match as best you can. Negative 1 divided by 1 gives us a slope of negative 1. I like those slopes, they're pretty easy. Negative 1 divided by negative 1 gives us a slope of 1. Negative 1 divided by negative 2 gives us a slope of positive 1/2. Continuing along the y-axis, all of those x values are 0. So 0 divided by 2 gives us a slope of 0. 0 divided by 1 gives us a slope of 0. And same thing with those negative values. All right, so at 1, 2, 1 divided by 2 is 1/2. 1 divided by 1 is 1. 1 divided by negative 1 is negative 1. And 1 divided by negative 2 is negative 1/2. And our last column, 2 divided by 2 is 1. 2 divided by 1 is 2. 2 divided by negative 1 is negative 2. And 2 divided by negative 2 is negative 1. So again, just sketching those slopes with mini lines as best you can. Obviously, I'm not going to look for it to be too accurate. I'm going to look that general shape is what it should be. All right, part B, sketch a solution curve that passes through the point 0, 1 on your slope field. We've done this before, so I'm going to go to the point 0, 1, and then I'm going to follow those slopes to the left and right. So off to the right, it kind of looks to me like it's sloping up like that, and then off to the left, kind of a similar shape. And finally, it says discuss the graph of the solution as x approaches infinity, or as x gets really, really large off to the right, and as x approaches negative infinity, or gets really, really small off to the left. So in both cases, my graph is going up, or my y value is increasing as my x value does. All right, so just as I was about to write that, my tablet that's supposed to communicate with my computer crapped out on me. So I typed it up for you. What we were discussing is looking at this particular solution as x continues off to the right and gets larger and larger, y value continues to increase or gets larger and larger. So that's this notation right here. As x approaches infinity, y approaches infinity. We also discussed the same thing happens as x gets really small, that y value still continues to increase. So as x approaches negative infinity, y still approaches infinity.